Hello and welcome everyone to today's webinar, DevOps meets DataOps, Oracle's end-to-end open telemetry observability across apps, Kubernetes, and database. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today, we're excited to show you how Oracle provides one-of-a-kind observability solutions for metrics, logs, and tracing across all tiers and aspects of an application, including the application itself, all the way into the database. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we set up a channel in our developer public Slack called Oracle Autonomous Database that you can access at the QR code or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We'll also be checking the Zoom chat and Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A after the presentation. Today's webinar will be presented by Paul Parkinson, Architect and Developer Advocate, and Herman Viscuso, Autonomous Database Community Manager and Director. So without further ado, I will turn it over to Paul.
All right. Thank you so much, Tara. We are super psyched to give this presentation today. Herman and I have been working on this, and we love observability. Real quick, Herman is a director of the ADB Community Management, and I am an architect and developer advocate for modern app dev and the database in particular. So I'll start with the subtitle, which is really long, which is our end-to-end open telemetry observability across apps, Kubernetes, and database. But really, it's the head title that is the point of this presentation. It's DevOps meets DataOps, and how Oracle really has this cohesive solution to get you end-to-end from your application into the database and top to bottom as far as depth. So if we move to the agenda, I'll just quickly describe some of the topics we're going to go over. And it's a lot of content. Herman's going to go into some details on the part that are good to have details on for the first three sections here, as far as Open Telemetry and open source, our powerful database operator, and open source exporters. And I'm going to take it over from there. And again, we're going to cover a lot. So I'm going to keep it at a fairly high level just to give you the full picture. So what's great about this presentation, I think, is that we're really covering all the different offerings that Oracle has. And as I say, it's such a comprehensive observability solution that you'll get the full picture through this. So I'll go through client and server tracing that we've added, Kubernetes tracing, which is a new area with eBPF, all the open source Grafana, Elastic, etc. support, our OCI APM solution, and then finally end with actually talking about the different Mongo stacks and observability there. And so with that, I'll hand it over to Herman.
Okay, great, Paul. Thank you very much.
You got it.
For covering the agenda. So we are going to talk about OpenTelemetry, and just to assess the audience, if you heard about OpenTelemetry, please raise your hand. I would like to see hands. And so we're going to, for those of you that are not familiar, we're going to talk about what OpenTelemetry is and why this big push towards OpenTelemetry. Okay, so basically, in a nutshell, OpenTelemetry addresses the generating and capturing of observability data. Okay, so this is a project that is part of the CNCF, the Cloud Native Computing Foundation, which includes Oracle as a member. And it has a very specific practical goal, which is sustaining an ecosystem of open source and vendor neutral projects. There are multiple very interesting projects within CNCF. So OpenTelemetry was accepted to the CNCF in 2019 because it became more and more popular, because it provides a common ground and a sort of standard, to put it some way, for observability in distributed systems. And this helps avoid a lot of the observability issues that arise when you're using different monitoring tools, different technologies across different clouds, different databases, different applications. You really need to have a standard for telemetry. And so But what is this really? So it is basically a set of tools, APIs, and SDKs. It's not a system per se to do observability, but basically it's a whole set of tools, APIs, SDKs, etc., etc. So when you use all of these tools as a standard, you have the possibility to instrument, generate, collect, and export telemetry data, and then analyze it and understand what's going on. So the best part of OpenTelemetry is that almost everybody is using it today, and it integrates really well with many products and extremely well across multiple Oracle products, as we will see. It is probably out of scope for today, but for example, OCI application performance monitoring is also using OpenTelemetry. Okay, so as I said, OpenTelemetry focuses on the telemetry, but it's not the system. Let's take a look at the Oracle database operator for Kubernetes, and I'm not sure if you are familiar with it, but you will be from now on, which could be seen as an important tool that we can leverage for database management and observability in Kubernetes environments. Okay, so we always wanted to make the Oracle database Kubernetes native, that is observable and operable by Kubernetes. So we created an open source this Oracle database operator for Kubernetes, and this is a way to extend the Kubernetes API with custom resources and controllers for automating the Oracle database lifecycle and also providing observability. Observability functionalities are upcoming, but we'll cover a big deal of those today. So you can expect to see a lot of the things that we will cover today straight into the OraOperator. With the OraOperator, we are at version 1 right now. It's a production release. So if you just search on the web, OraOperator, you will find a GitHub link, and you can go straight and start using it. It's pretty nice because it not only allows you to interface to a specific container-based databases. For example, you could have a 23C version of the Oracle database being a container running within the Kubernetes cluster, but it also allows you to interface to basically manage all the database services that live within OCI, including Autonomous Database, which is the team I'm coming from. So the OraOperator supports major Kubernetes distros and clouds, and it's obviously fully tested on the Oracle Container Engine for Kubernetes, or OKE. Okay, so basically running with Kubernetes 124. Here in this picture specifically, you can see a developer on the top using kubectl and a YAML script to install the operator in the cluster. So if you go to that GitHub project that I mentioned, you will find the YAML that makes things really easy for you to basically get up and running. If you go to the README, you will have all the instructions there. Then the cluster can not only work over containerized databases, as I mentioned before, but also over all these variants of Autonomous Database and all other database services within OCI. Note that the monitoring, logging, and metrics will be supported for observability via an observability controller, and we will talk about that later. It was in previous status for a while, but now has been taken out for rework. But if you're interested about what's going to be inside the controller, you can follow that bit.ly link right below observability. And in there, you will access one of Paul's live labs, where you can actually take a look at all the exporters and all the functionality that will be part of the OraOperator. So the goal is to automate the deployment of the database observability exporter, create the service monitor for Prometheus, and provide a config map containing JSON for a sample dashboard in Grafana. This is the goal. This is something that you will already see if you follow this bit.ly link in Live Lab, and you can use it, you can deploy it, you can repurpose it, you can use this, export this in any project, but later they will be part of this operator specifically, which I think is a pretty cool idea. Okay, so you can go to OKE, the Kubernetes platform for within OCI, and you can go to the add-on sections and go to the optional add-on sections, and these are components that you can choose to deploy in a Kubernetes cluster, and you will find the OraOperator. Okay, so I have flagged it there with in red, and once you do this, you will have the Kubernetes add-on extending the Kubernetes API with these custom resources, with controllers for automating the database lifecycle, the observability stuff when it's available, etc., etc., etc. So very easy if you're going to go if you don't want to go through that YAML process. Very easy for you to just go here and install the add-on. All right. So I mentioned exporters. What are we talking about when we say open source exporters? So this picture is very important because basically in very quickly, you can see that when we talk about observability, we are talking about three major pillars here, which are metrics, the telemetry, the data that is being produced periodically by the database, for example, or by systems. Then we have logging, which is another very important part, because logging is not just about accumulating logs, but you can always go into the logs and try to find a specific thing that is going on. Like, for example, we will see that when Paul starts talking about tracing, you might want to go to a log and correlate the specific thing that is happening within the log to a specific request, to a specific operation that is going on across a microservice, right? And then we have tracing. And this is what I'm talking about here. So tracing allows us to see things horizontally across probably multiple systems, multiple things that are going on, but maybe related to specific requests, to a specific atomic thing that is happening. Okay, so this is a high-level view of the cluster leveraging a set of exporters. There's three types of exporters to extract telemetry. These exporters are operating on top of the database. Here, I'm talking about autonomous database, but this can work with any Oracle database. And you might be familiar with some of the performance views within the database that are basically publishing these metrics and these logs, et cetera, in tables. And these exporters will be just tapping into those views to make this available to other systems, maybe to third-party systems like Grafana, Prometheus, et cetera. So why is this useful? Why are we talking about this specific use case? First of all, this is a single pane of glass observability platform. You can see everything at once. You can go you can take a look at the metric, and from the metric go to specific log, and then do tracing and correlate that specific metric with specific log. So this is basically everything put together and correlated, which is super important. But also this enables very interesting use cases like troubleshooting of code, like performance tuning of the database, generating specific alerts when something is going on. For example, one of those metrics could be an alarm because CPU utilization is going super high or something like that. Also high availability scenarios, capacity planning, et cetera, et cetera, et cetera. Okay, so I mentioned the three pillars of this observability platform: metrics, logs, and tracing. So metrics, let's focus a little bit on metrics. This is a flexible system. You could write your own code here to actually expose a metric from the database, and very quickly, thanks to this specific architecture, you can have it within Grafana, within a Grafana dashboard. So in this case, we are interested in transactional event queues total number of subscribers. If you take a look at the SQL code, this will be one metric. For example, you could be creating one of these metrics. See how easy it is? So this is basically SQL. We are tapping into one of those views that I mentioned. We are extracting some information, and we are making it available to the system. So as I said before, we are interested here in the total number of subscribers at a given point. And once in the Grafana dashboard, this value will be dynamically updated. So this exporter would be scraped, periodically, and all the information will be there in the exporter. So this is all running in Kubernetes. Even the Grafana instance, in this case, it is in the Kubernetes environments. And obviously the DB, thanks to this OraOperator functionality that I mentioned before, the DB could be in the container, but also the DB could be a database service, for example, within OCI in the case of autonomous database. So that's pretty cool. This is transparent to the system. All right. So logs. We have a similar situation here supporting logs. Raise your hands if you heard about Grafana Loki or Promtail, that kind of technology. So this You can also export logs to leverage them for observability. Grafana log is like Prometheus, but for logs. So if you never heard about Prometheus, it's like a time series database that works really nicely with Grafana. So Grafana log is the equivalent, but for logs. And Prompter is an agent that sends the logs to Loki. So it's basically an agent that is running on the machine to send the logs to Loki. So in this example, if we have an entry for the logs too, you could be writing this code here, which is also a SQL. And in this example, wants to get the alert log for the orders database. Here you can see that we are tapping into a specific bdiag alert X, okay, which shows the contents of the XML-based alert log in the automatic diagnostic repository, or ADR. And this works over a current container of the PDB. So this is a very specific way to strike a very specific log, okay? So this depends on what you need to expose from the logs. Obviously, you can always tap into the database and expose the information here. All right, so I'm almost done here. The Cloud Native Observability Controller. So here is a quick recap of the upcoming observability functionality in the OraOperator, thanks to the Observability Controller. This is going to be in the OraOperator soon. As you might have noticed, I made an intro to the metrics and logs exporters, but left out tracing. You see there that we have the tracing exporter, config Mac deployment. Now Paul is going to go deeper into distributed tracing. So Paul, all yours.
All right, thank you so much. As we're transitioning here, we're going to pop up a poll just to kind of get a read on if you guys have any idea what we're talking about. No, just kind of your background, you know, where you're coming from. Okay, excellent. So I'm going to start going into some of the, again, this is all OpenTelemetry based. So, you know, that is the theme of this. So I'm going to talk about some of the client tracing and server-side tracing that's conforms to the OpenTelemetry standard that we've implemented at Oracle. So first, what is tracing? And, you know, it's important to set the level ground here. So we're on the same page as far as distributed tracing being something that's actually been around, you know, for ages. But because of these new architectural systems and just more complex applications, you know, if you're using multiple processes, it's a microservice. You know, you don't need to be using Kubernetes per se. And, you know, you're using a complex application. Being able to know the flow of the activity in your application requires this tracing. So of the three, as they say, pillars of observability: metrics, logs, and tracing, tracing's the trickiest, maybe the most important in some situations, especially for these complex apps, and most unique, which makes it interesting as well. But it makes it something, you know, a problem that has to be solved. And whenever we, you know, present on this topic, there's a lot of interest, and that's why we spend so much effort trying to bring about this end-to-end tracing functionality in Oracle that we're talking about, because it's tough, it's tricky to do. Okay. So with distributed tracing, just to talk about the terminology a bit, there is a trace of your, you know, your business transaction or whatever your activity, your business activity is through the system. So someone, you know, is making a purchase at your online store, something like that. That whole purchase activity is a trace. And then a trace is made up of one or more spans. And, you know, generally in a complicated application, it's made up of a lot of spans. So it's a one-to-many relationship. And the spans can be anything. So it can be network activity, it can be application activity, it can be database activity. It's just that it's an atomic, as Ramon described nicely, it's an atomic operation that rolls up to an overall trace. Okay, so it's just good to know that basic terminology. And then a tracer is what's collecting these traces, and the actual tracing system, gathering it all to make the big picture, is the distributed tracing system. And then there's a context, and that's the information that's flowing on that trace from node to node. And there's a few different flavors of that, but we don't need to go into such particulars. And so what happens in a basic distributed tracing system is that each component is feeding its trace information to a collector. So there's the call graph is being made. The browser's calling microservice A, calling microservice B, calling the database. They're all feeding into a common collector. That collector is feeding to a tracing system, like whatever it may be, Zipkin, Jaeger, APM. And that's correlating them so that you can go into a visualizer and see that trace and drill down and do things like that. So again, one of the main points of this whole presentation is the fact that this whole path and into the database is something you can do with Oracle and you can't do with any other vendor. It's as simple as that. And let me get into the details here. So there are different options for this instrumentation, this taking of your trace information and putting it into the trace collector. One is the first one's the least desirable, the manual instrumentation. No one wants to do that. When you're really getting into the application, sometimes it's going to be necessary if you're getting real fine grained. But that's not desirable, especially if you're working with legacy apps. But just in general, you don't want to be putting these cross-cutting concerns into your microservices. You just want them to be pure, logic, your business logic, not all this extra security and tracing and stuff. The next is our agents. So you have your application, you attach an agent to it, and it can, whether it's using bytecode manipulation, like we'll see with Java or whatever mechanism it's using, it's taking information from your process and sending that trace information to your collector. And then the third option being built-in instrumentation. And we'll see that in some frameworks like the .NET we're going to talk about, where it's part of the framework. So you put the configuration in, and it's part of the actual framework itself to grab that information and send it to the collector, okay? So let's look at what we've done with the .NET. So we have support in all the drivers. We're going to talk about .NET and Java in particular, because they were the first and very commonly used. This is .NET Open Telemetry. So basically what's happening here is it's creating this activity source, starts an activity, collects this information, and it's, like I say, it's feeding it to the tracer. And so what you see here is some of the information that it's gathering by default. It's, of course, getting the trace information, the trace ID, the span ID, and the parent. It's the three, core points of OpenTelemetry to propagate. And then just various information as far as the system, including the start time, which, of course, you're tracing for a number of use cases, which Herman showed in the slide earlier, for performance, for troubleshooting, things like that. So the start times are very key. It's a very tricky thing to correlate, and so that's key. Okay, and so you're adding this configuration, in short, to get that information and send it to the trace collector. And then you're setting up the trace levels, etc. And so this is, with observability and tracing, security, well, anywhere security is important, but it's very important in observability, because you don't want to be sending, information that's sensitive as, passwords or SQL values or things like that. So you'll see throughout all the tech I'm talking about at Oracle, that security is, at the top of the list as far as considerations. And so that's what we have here. Okay. Now moving on to Java, onto JDBC. Here, there are advanced diagnostics in general, just even aside from tracing, that have been added in the latest JDBC versions. But in particular, we're talking about this for OpenTelemetry, we're talking about this Java agent. So that technique is used for Java. And so what's pretty great about this is actually, these Java agents have been around for decades. So when you run your Java code, you put a -Java agent, and then there's an API to inspect, using bytecode manipulation, what's going on in the Java stack. And so OpenTelemetry has created all of these libraries. And again, we're just using the OpenTelemetry standard and all the open source libraries, and enhancing them. So we're using that here so that we can inspect that on the JDBC client side and create, and this is the same with .NET, it's the same concept. We can create OpenTelemetry spans before and after we call into the database, and we can get information from the driver to put into those trace spans using these convenience APIs that have been provided. So that's one thing. We're automatically creating these spans with useful information before and after the database call. The second thing is we're passing the OpenTelemetry ID into the database. So we're propagating that into the database, and that's a huge differentiator. And I'll talk about that a bit more. But of course, we support all the standard endpoints as far as Zipkin, Jaeger, et cetera. Okay. So this is the API. I know this is a little small, but hopefully you get the idea. The API for the tracing agent in JDBC, you can access all this different information as far as the SQL, et cetera. And then this is showing, again, I'm showing a number of different consoles here just to mix it up and show you that we support every, popular product and open standard and open source. So here I'm just showing the Zipkin console that's showing the JDBC trace and then the information that's being gathered from there. So that's the client side. Let's move to the server side, the other piece of the equation that you need in order to provide this end-to-end tracing, okay? So what we are doing, or what we've done on the server side, is we're exposing and extending the Oracle database tracing to OpenTelemetry. So, OpenTelemetry didn't invent tracing. It's been around for decades. And of course, in the database, there's just patent upon patent of innovations that have been made in the database for tracing and logging. So, that's why you can just debug the database down to whatever level. So this is, very robust, and not to make, little of what's been done, but basically that powerful functionality is now translated into OpenTelemetry tracing, right? It's as simple as that. That's the concept. Is we have this amazing ability already. Now we're putting in an OpenTelemetry tracing format, and you can send it out to tracers, right? And so this is all versions of the database. It includes all the tracing functionality that's there, like I say, like including messaging. So if you're not familiar, there is a actual messaging engine in the database that you can access with JMS or even Kafka APIs. That's been there for decades. That's a whole other presentation that I'd love you to talk to you about. But we have a messaging engine, and you can do tracing with that. So you're already, if you're using that, you can the tracing for messaging as well. But as I say, this KS trace, which is in the Oracle database, is now extending this functionality out to OpenTelemetry. And it's extremely customizable, which is great for getting exactly what you want, really tuning things. It's extremely fast. And also for security, as I was mentioning, you can get down to a very fine level of security where I only want this information, and I want the information for this type of request to go to this collector. Right down to that level. And that's also unique features. You can get it down to use this collector for this application, use this for this. So you can really tune it down. And, if there's something wrong, if there's something that indicates an error in this request, put more into the trace, all that type of customization you can do because it's in the Oracle database already. But at the same time, it's very simple to set up. So, the most simple case is you just say, you set this environment variable. It says, take these traces, now export them in OpenTelemetry format to this collector, and set one variable, and you're off. Okay. So with that, we have the client side doing OpenTelemetry implicitly with the agent or whatever mechanism, sending it to the collector. We have the server side sending it to the collector. So now the collector combines them as I described, and you can correlate across the two from the client side to the server side. And that's the completely, unique and necessary thing. This is what everyone's been asking for, and that's what we're providing. And so now you can do that and correlate it. The next thing we're doing, which very soon, let me put it that way. I know this is already planned out and written, is actually using the same trace ID. So that propagation of the trace ID into the database, not just correlating it, but they're actually the same trace in that visualizer. Okay, so that's the end-to-end picture. And so what you see here is an example, like I showed you the trace on the client side. This is an example of the trace that's coming from the server side. This is a SQL statement going into the database. And then more to the point, that SQL statement, but you're noticing spans for all the sub-ops in the database. So you can get way down to the fine level of operation in the database and correlate that to, someone ordered something in your online store, and where did it go wrong, or where is it taking more time in the database or anywhere along the call stack. So pretty awesome. And like I say, I'm showing you different consoles. This is Elastic. I showed you Zipkin. Now I'll show you Jaeger. This is Jaeger showing a client-side trace and a server-side trace, and it's the same trace ID as I mentioned. So there's the first span you see there is on the client side, same trace ID. There's a client span on the added by the trace exporter on the server side. Okay, so hopefully you get the idea of how powerful that is. That's the end-to-end observability we're providing that's so unique. Now I'm going to go into a little bit of a different topic, something very new in the cloud native space in Kubernetes, which is this technology eBPF. And so you'll be seeing a lot more of this. And the OKE team, as German mentioned, that's the Kubernetes service in Oracle, in OCI. They've been working with this. And what it is it's this extended Berkeley packet filter, if that means anything to you. But what it does is it allows you to set up these probes inside the Linux kernel. Okay, so you're not rebuilding the kernel or anything like that. It's this framework to set up probes on that kernel and provide observability information from that kernel to an application that you write that's receiving that information. Okay, and so what this is doing is, I describe the end-to-end observability. This is kind of a top-down, like how deep the observability is, where you can go into not just into the Java drivers and whatever framework you're using, held on Spring Boot, Micronaut, but down into the kernel. So this is deep observability, as it says in the second bullet point here. And you can get, you can know when a file was moved from one place to another. You can know about all the network activity, things like that. And it's utterly transparent. So if you're familiar with service, you may be like, well, this sounds like a service mesh. So a service mesh does have that, ability to kind of sit on the side of your microservices, but that requires a sidecar. So you're still using some infrastructure there where you need to have a sidecar container in your pod alongside your microservice. Okay, that's not the case with this. This is transparent because it's all the way down at the kernel level. Okay, and it's very low overhead because you're just putting this, you're putting it so low that it becomes very optimal. And you don't have to manage as much, and it can do all this that I'm going to go into just a little bit. I just want to give you the idea of this. And there are a number of cloud native open source products that we're using that facilitate this all and make it easy for you to write these probes, to write these applications that interact with these probes. So as I just mentioned, here's just a visual of what I just mentioned. You set up or build a probe. And these exist, like these products that are out there. So you don't need to know, kernel. You don't need how to program a kernel to use this stuff. And then you write your program, and that program is receiving events from these probes. You attach to it and you start ingesting these messages. Okay, so you get all this great information, but you're not messing with the kernel. You're not breaking the kernel. You're just setting up these probes. Okay. So jumping up to its support in Kubernetes by providing this this workload template that you see on the left here. It's a rough example. We can use these kernels that have a probe attached to get the information, whatever it is, from the kernel and send these logs over. And then from the logs into the service connector, and then do log analytics on it. And what you see in the upper left here is the Oracle OCI APM log analyzer, which I'm going to be getting into in a minute, analyzing these logs, okay, that are coming from the kernel. And so not only can you do passive monitoring with this, but you can actually do proactive monitoring as well. Because you have access, you're not just reading, you have access to the kernel. You can do a number of things. For one thing, you can do some great security operations. For example, if something's gone wrong, you can shut down the communication right at the kernel level. Okay, so it's people are loving this for the security aspects of it. but you can also control the, the destination of the packets. So you can do routing and things like that, right? So if you kind of think of what a service mesh can do, this can bring it down, and, apply the policies and things like that at that kernel level. So there's less overhead, and it's optimized because it's so low level. Okay. So that gives you a taste of what's coming down the road, and that's the Kubernetes aspect. Now let's just go into very quickly. All I really want to point out here with this next point is the fact that Oracle is, you name it, and we have customers using it, and we support it with our observability strategy. Okay, so it's almost like a foregone conclusion, really. Of course, we are doing everything in Prometheus is essentially open metrics format, which is OpenTelemetry. So OpenTelemetry applies to metrics, logs, and tracing. And so, of course, we support Prometheus. All of our metrics and everything in Prometheus. All our tracing is OpenTelemetry, which is Zipkin, Jaeger, and of course, our APM product support. We support all the Elastic stacks. There are a number of people at the Elastic stacks and all, as well as the Promtail, Loki, Grafana stack, Splunk, New Relic, Dynatrace, Datadog, and Grafana. And just to give an example, it's just, as I say, we do support them, and everyone's using these very well because of the exporters and everything that I mentioned that Oracle's providing. It's easy to use open source with them, so I'm not going to go into depth on them.
Paul, we had a question about Datadog specifically.
Oh, okay. Yes, that's a popular one. Splunk and Datadog. There's always one question. Okay, let me check. It's in the chat, I guess.
Yeah, it's in the Q&A. I already answered.
Oh, okay.
I think that if Datadog can actually consume any of the data sources being exported, probably can work with it. Like, for example, Prometheus, but I'm not sure.
Oh yeah, for sure. That's a very common. Yep. Can you send that to Datadog? Yes, exactly.
Yeah.
Yep.
Please go on. Sorry for the interruption.
Yeah, no, it's perfect timing, because that's what this slide is trying to say. Yeah.
Right.
I mean, I just put Datadog here, but that's the idea exactly. Yep. Yeah, lots. Datadog's extremely popular. That may be, it's top of the list as far as what's used with Oracle and what we're talking about here. Great question, though. Thank you. So then I'm just returning to the slide that was shown earlier as far as an example of us supporting open standards. So we have these different exporters. You can bring it into Grafana, and all we're really doing here is making sure that we support Grafana, and Grafana is bringing, to be honest, some of the cool features. So we're exporting information from the app and database tier from DevOps and DataOps, and bringing it into Grafana, and then we're using some of its features to do this awesome correlation work that they have. So in Grafana, you can view metrics, logs, and trace, and from each of those, you can drill down into another. So on the left side here, we see, or let's start from the right to the left. On the right side, there are metrics. From these metrics, you click on a button, and it brings you into the logs. From the logs are parsed, and it looks for OpenTelemetry IDs. If there is one, as you see down here, it creates a button to your OpenTelemetry tracing system. So in this case, that's Jaeger. You click on Jaeger, that brings you to the left with your tracing. So you can use all the Grafana features because of the way we've presented the data from, Kubernetes. This extends to WebLogic and all the other SaaS projects. So, even though I'm talking a lot about open source, it extends to all these other products that Oracle has. And so now with that, we'll move on. We'll segue from you can do all this stuff yourself to OCI APM, which is the more I use it, it's really this is just such an awesome product because it's bringing in everything you see here. And if you're using, it actually is multi-cloud, but particularly if you're using Oracle tech, it's so well integrated. Everyone works with this team at Oracle. So you're bringing in anywhere you're working. It's definitely hooking into the O&M platform. and they're correlating it, optimally. Okay, so let me just go into a little bit of details on this because I don't want to spend all the time. But the application performance monitoring. So this nice, out of the box, you're getting nice dashboard setups like the one on the right here. So you're getting your distributed tracing that we've been talking about. You're getting your monitoring of real user data, synthetic monitoring, and different server monitoring. So you're able to get down into, as I say, again, this is like into the depths of it as well. You're able to get down into like Java applications and get into their thread dumps and things like that. And it's all automatically hooked in through this APM monitoring. So it's kind of like, being real, it's more than you're going to be able to do yourself. But even if you did do it yourself, you're going to have to keep updating. And this is, Oracle or not, it's a lot of work to update, keep these systems maintained, right? This is an observability system, but you need to observe the observability system to maintain it and to get the most out of it. And just, when you look at what APM has done and that they're going to be integrating all the new features as they come, this is an overall observability presentation I'm giving, but I'm just personally, the APM product, the more I look at it, it's just really awesome what they have here. So all the alarms, custom metrics, customizable dashboards for monitoring. The log analytics, this is fascinating because the analytics and AI and ML done on the logs will give you this, as it says, intuitive data visualization so that you can see, what's going on with your application very, very intuitively. The visualization is good. That's what it should be in an observability system, right? And again, it's multi-cloud. And it has the unified dashboards. All that correlation I mentioned in Grafana is in APM, and then some. So this, as I was mentioning, the intelligent log ingestion. So it's going to optimize the way it's bringing logs in, as well as metrics and tracing. But in particular, on the topic of log ingestion, and you're talking about Datadog, everything else, it's going to make sure it's doing that optimally for these systems, right? Because each system has a different. If you've ever messed with any of these, there's a lot of tweaking going on with all these observability components. Am I scraping every 30 seconds and then this is doing this and this is doing this? So it's intelligent about how it's doing this, and it's learning and optimizing. And then, of course, the real end-to-end advantage that it's also doing this database management, where it's doing the monitoring, and you can correlate that with your DevOps and DataOps tier as the title of this session. Okay. Right down to the SQL monitoring, as it says, real-time SQL monitoring. So you can really understand what's going on in your database. And that's just such a key differentiator of the Oracle database, but it's kind of brings it to light when you're looking at the analytics, like I can really know it's not a black box. I can really know what's going on in my data layer, which is just so important with applications these days using so much data. Okay. And this is just the end-to-end tracing concept that we've been talking about in short. And this is just showing the fact that you can bring tracing in from all these different areas. Okay, the Java applications, WebLogic's extremely integrated. It's multi-cloud, so you can bring in actual other clouds into the tracing system, and it's all in this one collector. And then this query language that you can use so that you can actually, query on your traces, which is very valuable to see what's going on them. Actually analyze the tracing, not just for performance and such, but to see what's going on in the system. And the end-to-end monitoring. Okay, so you can trace these user sessions, as I say. And then finally, the analytics or capacity planning. You can see what you're using in the cloud. And access the SQL warehouse for long-term SQL queries. So it brings in the analytics aspect as well, because it's kind of a gray line sometimes between observability and analytics, actually. I mean, they're two separate things, but when you can get these operational insights, then you can, actively tune your system. Okay, and then alerts and dashboards. So with that, I want to just touch on the last topic, which you may not have expected to see in this Oracle presentation, which is actually observability of Mongo stacks. So the typical ones being, the JavaScript where you're using Node and Express and either Angular, React, or Vue. Okay, so the Oracle database for a little while now, actually a couple of years, has had this Mongo adapter, and what it does, in short, is without any extra client libraries or anything, you can code to the MongoDB API, but it's backed by the Oracle database. So literally, you just take your Mongo application and you swap in the URL that points to the Oracle database. That is it. You don't need any extra libraries, so you can just try it. You can do an A/B test on it. They made it super simple that way. So it's awesome. And you get all the advantages of the Oracle database. Like if you ever know about the converged aspects, all these different data types, all the transactional stuff for microservices, all spatial, the AI ML, and all the robust, backup and reliability and autonomous features of the database. You get those, but you still get to just code to Mongo. So you can still put Mongo on your resume. But what we're talking about here is the fact that you're getting all this observability as well. And you cannot do that with the Mongo database. It is a black box when you hit it. They're not exporting and connecting the traces from the DevOps to the DataOps side the way we are. So this even applies to your Mongo stack. Okay. And
I would like to add something here. Sorry to interrupt.
Yeah, definitely.
I think that the very interesting thing of the Oracle database MongoDB adapter is that it's not like a high-level implementation trying to be Mongo-like, but basically it's a wire protocol implementation, which is exactly how Mongo is talking, to the different drivers, to the different tools. So you can use those tools on top of this API. Just wanted to add that.
Oh yeah, I'm glad you did. Yeah, exactly. That's awesome. Like you say, just take advantage of the whole, just bring it over, lift and shift. Yeah. So that's here are a few resources. I'll leave this up for a few seconds that you guys can follow up. Let's check out some questions.
I myself have one question for you, Paul. So it was a great experience for me to go through your live lab, your unified observability live lab. You were showing how you could go from a metric to the matching log, and then from the log, click on that Jaeger button and go straight into the tracing information. I actually tried that out myself, and I found it to be great, right? And I wanted to ask you about the exporters specifically. We are exporting several things coming from those database views that I mentioned in my sections. So I wanted to ask if you know, or if you remember, what is the interval granularity for tapping into those views? Like, are we talking about 1 minute? Are we talking about seconds? I would like to know how often those metrics are extracted from the database. If you remember, otherwise we can take a look at the code.
No, I do. And that's kind of what I was talking about, is that whole tweaking aspect. Because it is the default in Prometheus, I know well, it's 30 seconds. So if you don't set anything, it does it every 30 seconds. Yeah. And I'm sure that's a common, but for your system, your mileage may vary type deal.
That's pretty good, because when you go to the OCI monitoring service, for example, and specifically when it comes to autonomous database, you will often see metrics that are doing 1 minute intervals. Right. So 30 seconds sounds great to me.
Yep. Yeah.
So we have another one by Robin. Is the live lab mentioned a bring your own tenancy lab, or does it come in a sandbox?
Both.
We're talking about the unified observability.
Yeah, exactly. That is one. That's, as you say, that's my baby. I'm quite familiar with that workshop. And you can do, exactly, what's called green button or officially live labs, where you can use your own, or there's a sandbox that's spun up for you. So either option is there for that one.
That's another one. when you say Oracle APM service, you are referring to APM setup under observability and management
Yes.
section in OCI console, correct?
Yeah, I was wondering if I was going to confuse people because I switched back and forth. Yeah, I'm glad you asked that because I was wondering about that. Yes, that's right. It's APM under the greater observability and management APM. Yeah, thank you. That's funny where everybody's on the same
Nice.
wavelength. Yep.
I see that we have knowledgeable people. They know exactly
where
they should be looking at, etc. All right, there you go. Thank you, guys. Thank you for being here.
Yeah, thanks so much.